After the inspiring talk from Claudia, my task today is really to go through the role of AI in the future of energy. Let me put things a bit set the stage. I mean, for several years, we have been relying on a very central and fossil intense world where few generation sides were responsible to meet the energy demands at the country level and could be easily steered to some extent by just deciding the amount of fossil fuel to be burned. Things have been changing rapidly such that we can claim today we are experiencing an energy world revolution. There are three main aspects to that. The first is that the technology advances had allowed us to cost efficiently explore and exploit renewable energy sources such solar radiation, water, and wind, as Claudia already mentioned. In the same time, and for the very nature of these sources, the generation is happening increasingly in a decentralized way. This, of course, it's good. It includes, of course, utility scale power plants, solar or wind, but there are also a lot of small installations, for example, rooftop PV, that are really increasing the number of players and increase the complexity of the underlying system. Luckily, we have been experiences in the last few years an exponential growth of digital and IoT technologies. These are key enablers to connect such a decentralized world and can enable unprecedented ways of interconnection and cooperation between different players in the market. Let them be consumers, producers, utilities, grid operators, or policymakers. So you might say, we are done. We learned already from Claudia that we are not there yet. All of this really change and requires a fundamental rethinking of the way we have been using energy. On the one hand, we already learned that these sources are really volatile and they are intermittent. So they are really heavily depending on the environmental conditions as well as changes in the weather that can really require a lot of flexibilities, as Claudia mentioned. This is actually the reason why it's the world is really becoming very more complex, and the idea is that this increase of renewables in the energy mix increase the requirements that are required in order to coordinate renewable power plants and conventional power plants on the other side. What you see in the graph on the top right is the year-on-year increase of the solar infeeds as a function of the time of the day in Germany. And you see that the fraction of energy that was pulled into our grids from solar is increasing dramatically. What does it mean in terms of the steering of conventional power plants can be seen in the lower plots, where you see basically that we had, due to this increased penetration of renewable, we had to include deeper mid-morning ramp down and steeper evening ramp-ups of conventional generation power in order to meet the overall demand. And this, of course, requires coordinations, and which something that before was not there. We could just decide on a knob, okay, we need a bit more power, let's burn more coal or increase the energy, the nuclear fuel that we put in. There is another aspect that creates some challenges, is that, of course, renewables are really very volatile and can create stress in our distribution grids. So there is a higher likelihood of network congestions, and this can create supply and demand imbalances, which, of course, we don't want for security. Luckily, electricity is a very versatile matter, and we can really enjoy and exploit the interconnection, the interplays between different sectors. I think we'll hear something about that from Patrick later on. But particularly, we can use really these synergies between electricity, the electrical mobility, and the electrification of the heating and cooling sector to leverage these kind of challenges that we have. Clearly, this is not just an easy task. It increased the complexity, and is exactly here where AI can really play a role. Now, electricity or energy is not just about producing, transporting, and consuming it, but it's actually to orchestrate a myriad of players in the systems that needs to be steered and optimized in a way that we can all contribute to the decarbonization of the energy sector. So AI can really help us in several ways. I will give you a few examples later on, but in principle, you can think of AI to improve asset yield and efficiency and reliability. So we can really use this to implement advanced optimization algorithms and predictive maintenance tools. We can increase the forecast accuracy in order to be able to predict more accurately how much infeed we will get from PV or wind installations. But as well, we can also predict those congestion issues that I just mentioned a few minutes ago in order to enable proactive action to be taken. We can relieve this grid stress by exploiting local energy systems and applying demand response, for example, in the area of smart homes, and enabling peer-to-peer trading and flexibility markets. I will come to that in the following slides. And of course, we can also use the AI in order to forecast dynamics in the power market that will allow us, from a utility perspective, to decide and optimize the way we procure the energy for our customers. So how, when, how much energy should we buy and in which market? So let's talk about asset management. I think AI can really be helpful, for example, in various aspects, and can help us answering questions like what is the best layout for a wind farm to ensure maximum energy of the yield over time. So typically, and Claudia mentioned it, we have a wind farm built as arrays of wind turbines, which for economical scale are put in a small kind of space. And they are typically put into array, the layout is optimized in order to maximize the energy yield from the prevailing wind direction, which is shown here in the bottom of the slide. However, if the wind changes, and this happens quite frequently as we can experience it all over our days, there are negative aerodynamic interaction that happens and then can really reduce the power output of the farms. So this is a bit futuristic, but actually we are here at the Future Summit and think about having this layout in a dynamic way. And this can become a reality when we go, for example, for floating wind farms, which enable us to exploit wind energy also in deep sea regions. You can think of artificial intelligence to help building agents that change the layout in a dynamic way, such that if the wind changes, we can also reorganize the space between the turbines and maximize the energy. This is a non-trivial task because, of course, wind changes, it depends, the best parameters depends on the wind, incoming wind speed, and also on the operational states of the turbines, because imagine one of the turbines is down for maintenance, of course, the settings that you have to apply and the layout will change. But what if you have a fixed layout, for example, onshore wind or first generation of wind farm? You can ask yourself, how can we handle these negative turbine interactions in the best way? And can we build a control system that can learn this automatically? The answer here is yes, AI can help us. And what you see here is an exemplification of these wake effects or negative aerodynamic interaction between turbines. The wind is coming from the left, you have an array of turbines, and what you see for the different lines is the wind speed drops that you have after the first turbine, just because the first turbine is eating this energy in the wind to create power. The different lines correspond to situations where we change the blade configuration of each of the turbine to let more wind pass through. And what you see, by doing this, you can modulate basically the overall power of the array. By reducing the first, you can get up skills of the second turbine in the row, and all of these you can really do with reinforcement learning techniques, for example. But it's not all of this. We have the possibility to exploit artificial intelligence for asset optimization to help us determine what is the health status of my assets and its subsystems. And if there is an issue, when is a good time to maintain or send out fleet workers to really repair the things? Taking into account, of course, the availability of the spare parts, the accessibility of the sites. Imagine an offshore wind park, you cannot access whenever you want. There should be good conditions in the sea, you should have a vessel that is available to guide you there, and you have to have, of course, all the equipment with you. But as said, AI can support us also in the forecasting and planning. We need to know how much energy will flow into our systems in order that we can set up and dispatch the energy to meet the energy demand on the future. And for example, you can also decide maybe it's a good time to take power into gas, exploiting these new technologies to store some of this energy in the form of hydrogen or methane. But that's not all. So AI can make smart, decentralized, and flexible grid a reality. I mentioned at the beginning that we have an issue with the congestion management, and AI can really help us determining when there are risks for those situations to happen, so that we can proactively take countermeasures, for example, enabling local energy market by dynamic tariffs, so stimulating the local consumption of the energy, and we don't need to transfer it anymore, so solving the congestions. Of course, having precise forecast of the demand on the one side and the supply on the other allows us to steer in the optimal way assets in local energy systems. And we can also allow some communities to really work off-grid in an island mode. What you see in the graph in the middle is actually a representation that we have in a pilot at Simris. It's a small town in southern of Sweden, where we have 200 households that actually can, for an extended period, work off-grid and be supplied off-grid with the help of on-site renewables. So we have a wind turbine and a solar park, as well as a battery system that can be used to really isolate the community from the grid. And of course, it's not only that, just be isolated, but also about to determine when it's a good time to charge my battery to proactively react on a possible peak demand that is coming. And of course, if it comes to electric mobility and so on, AI can help us to determine where is a good place to place the new charging point. And if I have a fleet of vehicles, for example, that are going around during the day and they are parked overnight and plugged, what is the best steering of the charging schedule that I can achieve in order to increase the revenue of my customers and also meet and help the grid to solve some of the congestion that they have? And if you think about bidirectional energy exchange between e-mobility in general and buildings or the grid, you can really take it to the next level and have an integrated system where energy flows when it's needed and when it's more profitable and more sustainable. I mentioned about AI in several aspects. Of course, the same core algorithm that we use in the previous examples can be used really to boost the way we do energy economics. On one hand, we could use intelligent agents to build up autonomous and personalized trading robots, if you want, that could allow domestic trading. So you don't have a fixed tariff, but you can really decide automatically how to share and trade your energy from your own assets. At the same time, AI can help us boosting peer-to-peer technology by allowing us to decide when it's more profitable, for example, to sell the energy of my rooftop to my neighbors because I'm simply away, or, for example, when it's a good time to buy energy locally instead of getting it from the grid and saving some money. But again, as we said before, it's really an overall spectrum of possibility that AI opens in the flexibility market. So how can we best commercialize the flexibility of any of the assets that you can think of? Okay, e-mobility is one thing, but also think of deciding when you want to turn on your washing machine. And how much of this capacity can I really put available for the grid in order to enable the energy transition to become smoother? And finally, of course, you also want to become clever and be able to determine when it's a good time to buy the energy for your customer, as I mentioned before, and utilize basically AI and insights into the future to decide what is the best time to buy energy and which markets one should use. But I think a central point is, what does it mean for the end customers? I mentioned there are 3 points in the energy revolutions, and actually there is a fourth one, which is also very prominent, and is a human factor. It's the way we can engage with our customers and help them take active actions to really become part of this transition. So the goal is, and the key answer to the question that we want to answer is, can we, with AI, empower customers to take an active role and boost their sustainability? So to answer this, let's think about a near future where you can, instead of buying electricity, you could buy washing hours, for example. Or even better, think of a situation where you can actually wash your clothes for free, or maybe being paid, because you are amending a punctual oversupply in the network. So this thing's kind of futuristic, but it's something that we can do. We are rolling out a smart meter over all Europe, and this allows an unprecedented level of transparency of the energy consumption of every household or buildings that we can think of. With this data and AI, we can disaggregate the energy consumptions and identify what are the key player and the key consumer or the consumption drivers that are there for the industry, for the households, or for the final customers. And with this, we can compare and benchmark, for example, whether a household is doing well or not compared to similar assets, and detect anomalies that can lead the customer to take proactive actions. It can be de-icing a fridge because it's consuming way too much energy. It's a very simple thing, but if you don't know that this is happening, how can you take it to the next level? But I wouldn't stop here, actually, and in the frame of smart homes, we can really open new floors and new activities. For example, we can teach our house to adapt to our needs. We can know and anticipate what are the temperature settings that we would have, or would like to have before even we come home. Or let's say close the jalousie because there is a storm coming. Or decide, as I mentioned before, that we want to use the energy from our e-vehicles instead of buying it for the grid, because in that case it's first of all cheaper, but is also improving the overall sustainability of the energy system. And finally, I think this is an important thing that is a key kind of goal that we should keep in mind, is that AI and all this way that it can interconnect and interoperate a myriad of assets, let them be buildings, houses, assets that generates energies, e-vehicles or free-flow e-vehicles, and heating system, for example. This all allow the creation of what we call citizen energy solution. So where we have a community of people that actually engage to boost the sustainability, and we give them the power to do proactive actions and take part of that. So let me come to the conclusion and try to wrap up. I think there are a few points that are to take home today. I discussed about the energy wars and the revolution that is experiencing. It's basically 3 factors. We have decarbonization, we have decentralization, and digitalization. At the same time, we are really experiencing the wish from the customer to do more, to become more climate friendly. And in this case, in this situation, and for the success of the whole process, it's really critical to empower our customers and our people to really take an active role in the energy transitions and to improve their sustainability. AI extends the human capabilities, and here I would like to open a bracket. There is always some fear that AI will take over humanity at some point, but I think it's not the right way to see it. It's really extending our capabilities. I mean, all successful projects that we have been implementing in recent years could be done only because we could talk to the experts that have been in the field for several years and inject basically all the domain knowledge into the algorithms. It's really an interplay between human and machine that we can really exploit to be successful. And with this, if we manage to get this perfect link between humanity, the people, the creativity of the people, and the algorithms and the data, we can really have unprecedented opportunities to solve for fundamental problems of our society. And something which is really important is also to embrace these kind of technologies, but also additional technology breakthrough that will come in the coming years in a responsible way. You can appreciate that all this data that is created by a smart home and so have some implication about the privacy of the customers. So it's not just, rolling out algorithm, but also thinking what is something that is good to have and something which actually is limiting the freedom of our customers. If we do so, however, I'm really convinced that we can work and achieve a better tomorrow. So let's do it, and thank you.
Thank you. I have 45 questions, but I'll stick to one. So some of the people in the room, Andrei and some others, are also connected to something that's called a energy cooperative, which is mainly related to prosumers to some extent, to a large extent. How do you see possible in the future that local consumers or prosumers can use technology working with large companies, so not independently to as a competition, but to find a way to work together in this way?
Actually, I think the technology itself can be applied in many ways, and it's kind of available for everybody. I think the clear link is to have a connection between the two worlds, so the local worlds and the central worlds, in order to be able to understand when it's a good time to be independent. So I talk about off-grid solution. You can think of course, this was a small community, but you can think also of your house, and if you have a PV and a battery, you can at some point decide, okay, I disconnect, and it's fine. It's not always the best option too, because sometimes if you consume energy from the grid, you can really help the distribution network to overcome some energy surplus that's coming from renewables assets. Otherwise, you will need to shut them off. So it's really, I think the key is the interconnection and the flexibility between the local and the central view that will allow that. But the same algorithms that are used to steer, for example, local energy system can be applied at the home level and allow you to get increased autarky level and sustainability.
And you showed us something that AI could or might do, which is to help wind turbines move with the wind. How do they move?
So this is actually, I said, it's a more futuristic view. We have, the technology is quite mature to have floating wind parks, meaning that they are not anchored at the seabed, but they are just with some cables anchored in the sea. So if you could equip these turbines, for example, with some motors that would allow some movement, of course it was exaggerated in the slide to make the concept, but maybe a few meters is already enough to get out of those wakes or this shadowing effect. It's not only that, we have applied reinforcement learning on a test site in the US, and actually we show for a fixed kind of situations or layout that we could change the blades angles and optimize the energy in a dynamic way. So
Alex, I think you had a question? Yes.
Hello. So all of these solutions, they're very impressive, but personally I have a concern. Since we're talking about very complex systems of data and system, and knowing that a lot of security breaches have been happening even in the most highly qualified tech companies, how could we address that issue? Because I see a great deal of potential for this being easily hacked. Internet of Things right now these current devices are incredibly easily hacked, and the bigger the system, the bigger the vulnerability. How would you address an issue like that, or what's your opinion on how we could address it?
Now, first of all, thanks for bringing this up. It's a real critical aspect I didn't have the time to cover in the talk. So cybersecurity is really something that should be taken very seriously. I think there are some rules that allows us to mitigate these kind of things. For example, there are regulatory laws that doesn't allow you to steer assets remotely in some situation if they are critical. So you can deploy, for example, the algorithms that I just mentioned on site, on the edge, so not having it steer centrally, but you have an algorithm that runs locally. And of course, this makes the system a bit more resilient. But it's really a big topic and something that we should all think. It's not only about energy, of course. but for all the cases, water supply and so on, and or gas, it's also the same. So it's really a big challenge, but as I said, I'm sure we have the capacity. We have brilliant people around the world that are tackling this, and of course, looking for more to join to really make this a reality, and of course, overcome this kind of potential breaches.
Thank you very much, Giorgio. You can meet Giorgio at 12 in Mezzanine in a conversation about the future of mobility and energy, and you can interact more with him then. Now, thank you again.